Here we go again, as soon as possible, or ASAP, simple anatomy and physiology review. This is on the skeletal system, the second part of this review. Again, using the graffiti available from the Canvas site. Here we go. We had talked about the fact that, well, it is a system. There are organs. We identified the organs. Forgot to put a patella in here, by the way. There we go. We talked about some of the other tissues involved. We talked about osseous tissue, cartilaginous tissue, and dense regular connective tissue. Now let's talk about some functions of the skeletal system. There are things such as support, protect, movement, homeostasis, and storage. Start off with the idea of support and protect. When we look at things such as the skull right here, and the rib cage, and the pelvic girdle, and the vertebrae, the skull, particularly the cranium, is a bowl with a lid on it, and it fits perfectly the shape of the brain, along with a little bit of help from the meninges, but it's a perfect fit. And so therefore it is a shield, it's a helmet for the brain. The brain, by the way, has a consistency of sort of like thick jello, and so you absolutely have to have this cover around the thing. It couldn't take the bumps and thumps. More to be said about that later on. The rib cage. Encloses the lungs and the heart, and the lungs themselves are incredibly soft, and so therefore it's really important to have this cage-like structure around it to protect it. Then there is the pelvic bowl, and inside the pelvic region right here we have the end of the digestive system, we have most of the reproductive system, and the end of the urinary system, but it's very well protected by these flanking iliacs right here and that pubic bone in the front acting sort of like a face guard. Then we have the vertebrae, and in the vertebral foramen down the back right there, you have the spinal cord sliding down inside those rings. So for good examples here of how soft tissue is being supported and protected by the skeletal system. Oh, another thing to say about the support is stop to consider the only thing inside your body that's really hard or solid are your bones. And so therefore, if magically your bones just sort of disappeared right now, you would collapse the floor like a bag, and everything would be soft and squishy and whatever. We like to sort of mention that your skeletal system is sort of like the mast and the spars on a sail ship. The sails and the ropes don't stand up by themselves. They have to be held up. And so you are a skeleton with soft tissue either hanging from something or being cupped and supported inside of something. Next thing right here is movement. Now, the bones aren't responsible for the movement, but they're responsible for allowing the muscles to change the directions of movement. So for an example, if this be the leg right here, and here's the anterior group of skeletal muscles, here's the posterior group. If this one contracts, it pulls the tibia forward, foot goes forward. So by pulling, you allow the foot to go forward. If you contract the hamstring group back here, it pulls on the tibia, and it pulls the tibia backwards. So again, the muscles use the bone to change the position of the foot. And with this, you can take the pull of a muscle and turn it into the push, in this case the kick, of the foot. So the skeletal organs right here, these skeletal structures, allow the skeletal muscles to change the direction, to take a pull and turn it into a push, and again, of course, reposition the posture of the body and make it move. Hematopoiesis. Hemato refers to blood, and poiesis refers to formation. So this refers to the process of forming blood. And it's inside the red bone marrow that red blood cells, white blood cells, and platelets are created. This is the original source of all the formed elements of the blood. It is the only source for the red blood cells and platelets in a mature adult, and all the white blood cells originate in red bone marrow, even though some white blood cells, the lymphocytes, can duplicate themselves outside in the body, lymphoid tissue, and things like that. Next idea here is storage. There is a potential space in the middle, meaning of the long bones, and also the flat bones too. This potential space can house fat. So if that medullary cavity in the middle doesn't have red bone marrow inside, it might have yellow bone marrow. And if it has yellow bone marrow, that is a place where fat is being stored. And fat, of course, represents here stored energy. Well, inside the bone tissue itself, you have calcium and phosphate. As salts, calcium phosphate is storing away these two chemicals that are extremely important for metabolism, so many ways, but they're being used while they're being stored as structure. So it's as if you have a gingerbread house. It is a house held up by gingerbread, but the gingerbread itself has another purpose to it. And this one right here, okay, you have the bones. They are created of this material right here that later on you might want to break down and use in some other fashion. Well, real quickly here, let's look at some common designations of bone shapes. We can talk about long bones, short bones, flat bones, that's what that's supposed to be, sorry, and irregular shaped bones. Now, this isn't a very it's a scientific way of identifying bones, but it's very good for conversation. A long bone, of course, is longer than it is wide, so it looks like a stick, and it's sort of like that Fred Flintstone kind of bone that people think about. The short bone is about as wide as it is tall, and so therefore it's a bit more like a cube. And the flat bones are flat like panels, and the irregular bones, like a vertebrae, just defies description. It has no sort of common, easy shape to it. Now, an example of an unusual bone is called a sesamoid bone. The sesamoid bone is an example of a short bone. It tends to be sort of pellet-shaped, and by its name, it literally means shaped like a seed. Now, sesamoid bones tend to be found inside tendons, and they formed inside tendons. So a fine example of this would be the patella that I had forgotten about earlier. The patella starts off as a pad of cartilage inside the tendon that connects, where are we at? That connects the anterior group, muscle group of the thigh to the tibia. And so inside this tendon right here, there is a pad of cartilage. Now that pad of cartilage under stress can calcify. And when it does calcify, it then gets known as a sesamoid bone. So sesamoid bones tend to form inside tendons, usually in an area where there's a unique amount of stress. And the patella is a common example that just about everybody has. However, you may have a sesamoid bone that other folks don't have. It turns out that if you use your hands a lot, at the base of your thumb, those tendons right there that are used to sort of close your hand, close your thumb, if they're put under a great deal of stress, they might begin to form little bits of calcification, which will then become sesamoid bones. And the person may not know this is happening until perhaps someday he just happens to have an x-ray done of his hand and notices that there's something at the base of his thumb that kind of looks like he was shot by a BB. That's a sesamoid bone. So, because people can form sesamoid bones inside tendons and it's not consistent with everybody, that's one of the reasons why we say you have approximately 206 organs in the body, skeletal system, and we're not absolutely sure how many you do. Okay, let's take a look at, there we go. Let's look at the general features of a bone, a long bone. Okay, here are the general regions. First off, there is the epiphysis, this knob-like structure right here, and there's another epiphysis down here. So epi means upon, and they're upon the ends of this shaft. So here's one epiphysis, here's another epiphysis. Plural would be epiphyses. Again, they tend to be knob-like. The long shaft-like section of the bone is called the diaphysis, and di is a pretty good prefix because it means across, like in diameter. And then between the epiphysis and the diaphysis, this neck region right here is often called the metaphysis, where meta refers to in between, as in mitosis. You talk about prophase, metaphase, and anaphase, where meta means the chromosomes are towards the middle, and this is that in between step. Well, the metaphysis right here is a place where you might find what's called the epiphyseal plate or the epiphyseal line in a bone. So sometimes this region right here is called the neck, sometimes the metaphysis, or sometimes they refer to it as the growth plate. The epiphyseal plate is that section where hyaline cartilage still exists. When the hyaline cartilage disappears, then it's called the epiphyseal line. And it represents the potential for the bone growing longer and when that potential is gone. And this tends to be there until a female is around age 17 or 18. And for a man, that tends to be there until they're about age 20, 21, something to that effect. So the growth and the length of the bone is possible as long as there's cartilage inside this epiphyseal plate. But when the cartilage is gone and it's just bone there, the possibility for the bone growing longer is gone, and now that line is called the epiphyseal line. More about that later on. If we were to look at a cross-section of the epiphysis of a long bone, we tend to see that it has a kind of a thin outer shell of compact bone and then a large area of spongy bone to the inside. If we were to cut across the diaphysis, we tend to see that the amount of compact bone is greater and there's less proportional amount of spongy bone. By the way, one way to remember this is when a dog is chewing on a fresh bone, they'll go after the ends of the bones first. And that's because they can break through that compact bone a whole lot easier here than down here. And what the dog is probably after is the contents of the spongy bone area, which would probably be red bone marrow or yellow bone marrow. Well, by the way, since we're talking about the ends of the bones right here, something we expect to find on the end of the epiphysis is articular cartilage, which is hyaline cartilage. And it's hyaline cartilage by composition. It's called articular cartilage because of its position. And so we see some here and we see some down here. Now, the articular cartilage is going to act a little bit like a cushion, a little bit like a smooth surface. This could have a synovial joint right here, in which case this would be facing a fluid-filled space. But the cartilage right there, again, is the ending, the relatively smooth, cushioned area on the ends of the bones. Although in a synovial joint, we don't expect the articular cartilage of one bone to come in contact with the articular cartilage of another bone. This articular cartilage, by the way, is just a leftover from the embryological development. If for some reason it were to disappear and the solid bone were exposed, that would create a great deal of trouble inside that joint right there. If the bone in here grows a little bit too dramatically, you end up with a bone spur, and again, that leads to a lot of problems when it comes to the joints. Back to the silly way to remember this, that dog, when he went after the bone, one of the things he wanted first was that articular cartilage to the outside. And this is something you can see when you're, say, cooking chicken. In the uncooked chicken, you look at the end of the drumstick and you'll see a clear pad on the end of the bone. After the chicken has been cooked, that clear pad becomes kind of white and not flexible, but it's brittle. It looks like plastic. It is made of hyaline cartilage. It does have a lot of collagen inside, so therefore it does have a nutritional value to it. Last thing right here, let's talk about the medullary or marrow cavity. You call it the medullary cavity if you're talking about where it's found. It's in the medulla, the middle. You talk about marrow cavity if you're talking about what's the content of this space right here. And the content could be either red bone marrow or yellow bone marrow. If it's red bone marrow, there's still a metaphysis taking place. If it's yellow bone marrow, well, the metaphysis is pretty much over, and now what you have here is fat being stored away. It's sort of kind of like you had a factory that was doing something. If the factory shuts down, it turns into a storage area. Here's a quick picture of the relationship between the compact bone and again the spongy bone. Notice the spongy bone is made up of these strange little pillars, but there's a potential space between the pillars. That's where the bone marrow would be located. Good place to stop. Pick it up in a second.